In Math 101, we spent some time discussing simple interest. The formula for simple interest is I is equal to P times R times T, where P is the principal, R is the rate, and T is the time, always expressed in years. Here we are going to start to talk about compound interest. With compound interest, the interest amount is added to the principal amount in each period, and that new principal continues to get interest. I have a formula that can be used for compound interest written down here at the bottom. S is equal to P, and then in parentheses, 1 plus R over N, end parentheses, and that to the NT power. And you can see over to the left what each one of the variables stands for in this particular formula. So we are going to use this formula, and we are going to do a problem with compound interest. Here is an example on a problem dealing with compound interest. What is the compound amount on $5,000 invested for 2 years at 12% compounded quarterly? In order to go through and do this particular problem, what I am going to do is I am just going to substitute the information that's given in the problem into the formula. I don't know what the compound amount is, so that's the S, but I do know what the principal is. The principal is that $5,000. So I'm going to have S is equal to 5,000 times, in parentheses, 1 plus. The rate is up here, it says 12%. I want to write the rate as a decimal, which would be 0.12. The N stands for the number of times it is compounded in a year, and it's compounded quarterly, so it's divided by 4. All to the NT power. N, once again, is 4. T is how much time in years, so it's 2, so I'm going to multiply that times 2. Now I'm just going to go through and solve this. So S is equal to 5,000. 1 plus 0.12 divided by 4, you can certainly use a calculator to do that. You get 1.03 to the 8th power. And then I need to figure out what is 1.03 to the 8th power. When I figure that out, certainly you want to be using the y to the x key on your calculator to help you figure that out, but you are going to get that 5,000 times 1.03 to the 8th power is going to give you a long number. And since you're using your calculator, I would just leave that long number right inside the calculator. I get 1.26677,008, and then I'm going to multiply that by 5,000. So I get a final answer of $6,333.85, rounding it off to the nearest penny. Now, if you do it on your calculator and you get something a little bit different than this, it may be just because your calculator does not go out that many digits, but it's not going to make a huge difference as far as the final answer. If you got 84 cents or 86 cents instead of the 85 cents, that would certainly be fine as well. Here's another example using different numbers. What is the compound amount on $10,000 invested for 5 years at 6% compounded daily? You may want to pause this, do the problem yourself, and then turn it back on again and see me do it. Okay, hopefully you've had a chance to go through and do that particular problem. All I'm going to do right now is I'm going to plug that information in. I want to know what the compound amount is, so that's my S. My principal in this particular case is $10,000, and it is 1 plus. The rate is 6%, so it's 0.06. And it says it's compounded daily, so we are going to use 365 days in a year for the N, and we need to take that to the NT power, so that's 365 times the time, which is 5 years. Now I'm just going to go through and solve this. So when I go through and solve this now, I have $10,000 times, now that 0.06 divided by 365. Once again, I am going to do that on the calculator. I'm going to add 1 to that. So it's going to be times 1.000164, and now that is all to the 1,825th power, multiplying 365 times 5. Once again, use the y to the x key on your calculator, and you're going to find out that this 1.000164 to the 1825 power, that is going to be giving you an answer of 1.3498242, which I am going to be multiplying by that 10,000. The final answer for the problem is $13,000, $498.24. So if I put that money in and left it there for 5 years at 6% compounded daily, that's the amount of money I would have after that 5 years. Another formula sometimes used is the present value formula. Present value is really the opposite of the compound amount formula. By present value, we mean what amount do I need to invest now into a bank under certain conditions so that I end up with a predetermined amount. Here's the formula. P is equal to S times, in parentheses, 1 plus r to the n, this time to the negative nt power. And once again, all the variables mean the same thing as in the compound amount formula, but I have them listed over here, over to the right. One thing to notice, I'm going to rewrite the compound amount formula here. And notice that the compound amount formula is very similar to the present value formula. Here's the compound amount formula, and notice that only a couple of things switch. The S and the P switch around because now I am trying to find in the formula that we're working with right now, the present value, I'm trying to find the present value. And also, instead of an n to the t power, we now have a negative n to the t power. Here's an example of a present value problem. How much must be invested at 10% compounded semi-annually so that $1,000 will be accumulated at the end of 2 years? In other words, it's saying, if I want to make sure I have $1,000 in my account in 2 years, under those conditions, how much do I need to put in today? In order to solve this problem, we are once again just going to go through and plug the information that we are given. It says that the P is what we want to know. We want to figure out what the principal is. But I do know that I want $1,000 in the account. So that is my S. It says 1 plus, the rate is 10%, so I'm going to write that as 0.10. And it says it is compounded semi-annually. Semi-annually means twice a year, so the n is equal to 2. And now it is going to be to the negative nt power. So that's going to be to the negative 2 times 2 power. So now I'm just going to go through and solve this. So I get P is equal to 1,000 times. Now 0.10 divided by 2 gives me 0.05. Certainly you may use a calculator to do that. So I get 1.05 to the negative 4th power. Now, different calculators work different ways to figure out what 1.05 to the negative 4th power is. Once again, you will go through and use your y to the x key in order to do that. And when you do that, the calculator will tell you that 1.05 to the negative 4th power is equal to 0.82270. So, multiplying then that by that 1,000, I get P is equal to $822.70. So if I put $822.70 into the account today, under those conditions, in 2 years I would have my $1,000. Please don't worry about memorizing any formulas for this particular module. Any needed formulas will be given to you during the assessments. If you want to practice more problems of these types, you can certainly do so, and I have included some in this module. There is one more type of financial problem to solve in the module, known as annuities, and you will find information about those types of problems in the next video.